So the question is the 11th question, where the compound microscope consists of an objective and an eyepiece. The objective of focal length 2 cm, eyepiece of focal length 6.25 cm. Eyepiece's focal length will obviously be larger because eyepiece is larger in a compound microscope. Separated by a distance of 15 cm. This distance of separation is given to be 15 cm. How far from the objective should an object be placed means u is equal to what? In order to get the final image at the least distance of distinction, which is 25 cm. Okay, so then the VE is the final image, which is the least distance of distinction, which has to be taken as negative because it's on the left side of the eyepiece. This eyepiece and the left side of the eyepiece, therefore it's negative. 1 by FE is equal to 1 by VE minus 1 by UE. Let's fill in the sign conventions. 1 by FE is the focal length of the eyepiece, which is positive 6.25. Because convex lens, the focal length is positive. 1 by VE, which is minus 25, minus 1 by UE. Therefore, bringing the 1 by UE to the other side is minus 1 by 25, minus 1 by 6.25. 25 is 625, so we can still write this as 6.25 is LCM. So, because it can be 0.25 into 0.25, so it will be 0.25 minus 1, which will be minus 1.25 by 6.25. Let's multiply both the numerator and denominator by 100. 125 by 625. 25 5s are 125. 25 is 625. So can I say UE is minus 5 centimeter? Obviously, because UE, this is your VE, the final image, which happens to be 25 centimeter. This is your UE, correct? So then UE you found it's also to the left, so of the eyepiece, so minus 5 centimeter. Now you got your UE, which will be, therefore you can find your VO, the image distance for the objective. The total distance between the objective and the eyepiece is 15 minus the UE that you got. What is the UE that you got is 5. Let's take only the magnitude 5. So 15 minus 5, this will become 10 centimeter VO. And it's the right side, it has to be positive. And you take the focal length of the objective. 1 by FO is equal to lens formula 1 by VO minus 1 by UO, and you want to find UO, VO is 1 by 10 and FO is the focal length of the objective, which is given to be 2, is equal to, what about focal length is positive because convex lens, so 1 by UO is equal to 1 by 10 minus 1 by 2, and the answer itself will be 10 is the LCM. 10 minus 5 is minus 5 by 10, so 1 by 2. So, no, into 5. So, sorry, this is 10 is the LCM. 10 minus 5. No, not 10 minus 5, it's 1 minus 5. So, 10 is the LCM. 1 minus 5 is minus 4 by 10. And so minus 2 by 5, and that will be my UO, which is minus, you have to reciprocal it, don't forget, 5 by 2, which is minus 2.5 centimeter, is where you have to place the object. This seems to be like a compound microscope sum, but this is, I have not used any formula related to compound microscope. They haven't asked me M is equal to MO into ME, or M is equal to VO by UO into 1 plus D by F into 1 plus D by FE, or minus L by FO into 1 plus D by FE. I haven't used any of these formulas. So it's ideally like two lenses, convex lenses together, and so then they will ask you this question for sure, but it has to be approached like an ordinary sum. Okay, so the next is, of course there are questions in continuation of this in this question, such as they ask for what happens if the final image is at infinity. When the final image is at infinity, it's called final image is at infinity. When will you get final images at infinity for this? The final image has to be at infinity. Can you imagine? The VE is infinity. 1 by infinity is 0. FE will be equal to UE. And so then what is the focal length of the eyepiece? Will be UE. So you immediately found the UE to be minus 6.25 centimeter. You have to subtract it from 15 so that you get the Of course, ignore the negative sign and subtract so that you get your VO. And once you get your VO, you can use this formula and get your UO. It's the same sum as last, but only thing is V is infinity. You can try this sum on your own. And this is the second part of the question. Please see Aurora. Keep your Aurora open when you do the sum. And then find your UO. And the UO turns out to be minus 2.59, which is even closer. So that's about this sum. And they're asking magnification. M is equal to MO into ME. MO is VO by UO into ME is VE by UE. VO by UO, everything VO, VO, UO, VE, UE. You can substitute all the values and get your, because in this question, that's the way they started. They gave you initially VE, with which you found UE. After you find UE, you did 15 minus UE and you got your VO. Once you get your VO, you used Lenz's formula for objective to get the UO. So you know all these values. So correspondingly substitute in magnification and get your answer. So that completes the 11th question. So this will come for everyone when they say optical instruments. This whole question will come. And so let's go to 12th question is ignored. Okay, that's an omitted portion. No, it's there. 12th question is there. I'm sorry. A person with a normal near point is least distant of distribution 25 centimeter. Compound microscope with an objective of focal length 8 millimeter, 8 into 10 to the power minus 3 meters. An eyepiece of focal length 2.5 centimeter, which is 2.5 into 10 to the power minus 2 meter, can bring an object placed 9 millimeters. So an object distance has been given from the objective, which means UO has been given, which is minus 9 into 10 to the power minus 3 meter. In sharp focus, what is the separation between the two lenses? Capital D. This D is different. I'm talking about the distance between the objective and the eyepiece. This distance. Let's call it a small d then. They're asking this distance. So in this sum, you know your UO. Therefore, we can find your VO. 1 by FO is equal to 1 by VO minus 1 by UO, and FO is focal length, which is 8 into 10, 8. Let's do the sum in meters. 8 into 10 to the power minus 3 is equal to 1 by VO. We don't know, we're going to find that. And UO is plus 1 by 9 into 10 to the power minus 3, because minus of minus will become plus. So 1 by VO itself is 1 by 8 minus 1 by 9. Of course, there's a 10 to the power minus 3 which goes up as 10 to the power 3. So let's solve this. So then what will be the LCM between this and that is 72. So into 9 into 8. So 9 minus 8. Can we call it as 1 by 72 into 10 to the power 3. So then therefore it's you have to reciprocal it in order to get a VO. VO therefore is 72 by 10 to the power 3. Or if you want the answer in meters, 0.072 meters. Okay, 3 decimal places before. Or if you want the answers in centimeter, it will be 7.2 centimeter. They have kept it in centimeter finally. So you can also keep it in centimeter only. Now you got a VO. You know that. Now take, you got a VO. The distance between the, I would approach the sum a little differently. Let's consider that the distance between, okay. I would think of D is the separation between the two lenses. Minus 7.2 will be my UE. I would think of the sum like that. Okay. Let's do it. Even if I go wrong, let's think of it like this, because it makes sense, right? So then if you get your VO, and a D minus VO will give you your UE, and once you get your UE, you can find your VE using 1 by FE is equal to 1 by VE minus 1 by UE. The focal length of the eyepiece has been given. It's given to be 2.5 into 10 to the power minus 2. They seem to be doing the sum in centimeter. You can also do that. Is equal to 1 by VE, you don't know, but you know UE is, for the second lens, UE is negative. it's on the left side, so it's negative, and so you can write plus 1 by d minus 7.2. What is the use? I cannot solve because I don't know d, I don't know v. So what you do is, have they given that the final image is obtained at least distant of distinction? A person with a normal near point using a compound microscope with an object with a normal near point sees the object and bring an object to focus, which means he's seeing at capital D. Therefore, you understand that he is seeing the final image like last sum at capital D. It's indirectly been specified, which is 25 centimeter, which will be minus because it's VE is to the left side. Okay, so with which you can find UE 1 by FE is equal to 1 by VE minus 1 by UE. So 1 by FE, you know the focal length of the eyepiece is found to be 2.5 × 10 to the power minus 2. So 2.5 centimeter, keep it in centimeter only, because we found this also in centimeter. You can, 1 by minus 25 minus 1 by UE. So 1 by UE comes this side, minus 1 by 2.5 minus 1 by 25 minus 1 by 2.5. The LCM will be, can I keep it as 25? So this gets multiplied by 10, minus 1 minus 10. So can I write it as minus 11 by 25? And so I have to reciprocal it. Normally I forget to reciprocal. Make sure you're doing a reciprocal of it. Minus 2.27 centimeter is my UE. So once you get your UE, in this, remember always that when you get in the final image at D, the separation between the two lenses, if they ask you separation between the two lenses, you can take it as, the interim image will be formed here, which will be a VO and your UE. When you add VO plus UE, that will be the distance between the objective and the eyepiece. So then therefore it's 7.2 plus 2.27, take only the magnitudes and add, and you get the answer. 9.47 centimeter will be the distance, and then thus you got your small d. So I just simply tried with d minus, but you can't do the sum there. Previous method that I did, I hope you're clear with this method. So once you get this, they are asking for magnification, which is MO into ME, which is VO by UO and VE by UE. You know the respective values. Is it? No, this is not VE by UE. It will become 1 plus, substitute that formula, 1 plus D by FE, because VE is not VE, it is at least distant of distinction. So whenever there's least distant of distinction, you're supposed to write VO by UO into 1 plus D by FE. And it's just put this magnification and you get it as 88. Substitute those respective values. D is 25 centimeter. And you get the right answer. So let's go to 13th question. So when they say it's optical instruments, these are the questions which will definitely come. Example 11, the sum number 11, sum number 12, then sum number 13. These are the sums which are definitely going to come. A small telescope has an objective of focal length 144 centimeter and an eyepiece of focal length 6 centimeter. What is the magnifying power of the telescope? Magnifying power of the telescope, M is equal to FO by FE. We just saw it, provided the object is at infinity. A small telescope objective of focal length so much. What is the magnifying power of the telescope? This is for a normal adjustment. As I said, normal adjustment always means that normal adjustment word is associated with image is obtained at infinity. Image is at infinity. So then that's the formula. M is equal to FO by FE. Of course, we have a negative sign. We can ignore it because we're just going to write the answer in magnification's magnitude. So that's, you get this 144 by 6. Separation between the objective and eyepiece. In this sum, you know that the telescope is like this. The eyepiece is smaller. The ray comes here and comes and converges like this here. You get an interim image which serves as an object for the second lens. And this is at infinity, which means this is FO and this is FE. That's the condition, right? So you know that the distance between the objective and eyepiece will be FO plus FE. And so it's 144 plus 6. So it's 150 centimeter. Okay, so if you're clear with the theory part, then everything becomes easy. So let's go to 14th question. A giant refractive telescope at an observatory has an objective of focal length 15 meters. If an eyepiece of focal length 1 centimeter is used, which is 1 into 10 to the power minus 2, or you can convert that into 0.01. This is ideal. If an eyepiece of focal length 1 centimeter is used, what is the angular magnification? See, the previous question, what is the magnifying power of the telescope? The previous question I did where M is the magnifying power. Magnifying power. Here they are asking what is the angular magnification. Okay, 1 second, hold on. So while addressing this question, I'll also explain to you in general the difference between magnification and angular magnification. The magnification, or we can even say linear, generally magnification refers to linear magnification, the ratio of the image size, height of the image by height of the object. So the ratio of the image size to the object size. Whereas here it's tan theta, tan of the angle subtended by an object. Tan of angle subtended by the object, and by the tan of the angle subtended by the image at a given point. At any point you can find angular magnification. At a given point you can see like how is the object angular magnification, how is the image angular magnification. Okay, it seems like a tan of the angle subtended by an ratio of the tan of the angle subtended by an object and by the tan of the angle subtended by the image at a given point. This depends on, it doesn't depend on the position of the observer. Wherever the observer is, you can say how magnified the linear magnification is, but this depends on the position of the observer. As viewed by the observer, this whole angle is as viewed by the observer, by the observer's eye. Probably you can say observer's eye, the angle subtended at the observer's eye. Depends on the position of the observer. So in general, this is what you need to understand. But coming back to this question, hope it's recording. 35, yes, recording. So where is the question? Question number 14. They're asking for angular magnification of the telescope. The telescope, okay, the angular magnification of the telescope, they have just written M is equal to FO by FE. FO is given to be 15, FE is given to be 0.01, they have just written it to be 1500. So that they have just referred this also, because we did it using 4 by FE. In fact, angular magnification should be done using beta by alpha, which is the image subtended angle to the object subtended angle. Tan of the angle subtended by image by tan of the angle subtended by object. And eventually I got this to be FO by FE, so I am able to use this formula. Okay, so then therefore this answer is correct. Okay, so just leave it like that. Next is the second part of the question. If the telescope is used to view the moon, so supposing this is a telescope, this is your objective and this is your eyepiece, and it's observed to view the moon. Let's take this is the ray which is coming and falling like this, going through the optic center. So this will be the, say, let's see the moon subtending an angle, and let's take this to be the diameter of the moon, considering that the moon is located here. You have to imagine the moon is located here and the light rays coming from that corner. Or I would actually say, okay, just thinking about it, let me think about the sum. Supposing the moon is here and the ray is coming like this, then it converges here. And anyway, this is your alpha. And this will become your alpha, vertically opposite angle. And this will be the diameter. Okay, ideally this should be the drawing, and I'm not agreeable to what he has written in the book. I can't imagine what he has written in the book. So for me, this is the diameter of the moon. It makes sense, right? that's the diameter of the image. Okay, so that's what I can think of. And so when I do tan alpha is the diameter of the image by this distance, which obviously is the focal length of the objective. And that using similar triangles, if I'm going to use similar triangles, that's the reason they have taken this as the moon's height or the diameter, so that this vertically opposite angle is there. And so by symmetry, this triangle will be similar to this triangle, and hence by similarities you can also equate it to diameter of the actual moon, not the image, diameter of the moon by the diameter of the moon by this distance. What will be that distance? Isn't it infinity for us? What do I do? That is the distance between the moon and the earth. Yeah, that can be the distance between the moon and the earth. Let's say radius of the orbit. Okay, in that case you have to by using two similar triangles you got this. If you know the diameter of the moon, they've themselves given diameter of the moon, so take this as diameter of the moon 3.48 into 10 to the power 6 by the focal length of the objective. The objective's focal length is 15 or whatever has been given. Objective has focal length 15, yeah, is equal to meters. Is it meters? Yes. Diameter of the this is diameter of the moon, so it has to come here 3.58 into 10 to the power 6 by 15 by the orbital radius has been given, which is 3.8 into 10 to the power 8, which is the orbital radius, which can be equated to diameter of the image. You don't know the diameter of the image by the focal length of the objective. You know the focal length of the objective to be 15, so you cross multiplying, you get a value. In this sum, what I find it tricky is you have to assume that the moon is here and this is the radius, and you're looking at it from, if the moon is here, the rays can also come like this and can come like this and it can still converge, right? So it doesn't matter, you have to take the diagram like this, otherwise you can't do the sum. So that makes the sum harder, but it's very, very easy once you assume your assumptions are correct. So let's go to next question. The next question is the next question is also omitted. So 16th question is there. A small pin fixed on the tabletop. So 16th question, a small pin fixed on the tabletop is viewed from above from a distance of 50 centimeter. By what distance would the pin appear to be raised? Which means you're obviously looking at it. Oh, the tabletop. Can you imagine one glass will be there? One pin is stuck inside. So when you're looking at it from sideways, the pin will appear to be raised. Correct? It's like a glass slab only, no? So it's viewed. By what distance would the pin be raised if it's viewed from the same point through a 15 centimeter thick glass slab held parallel to the table? 15 centimeter thickness is the glass slab. A small pin fixed on the tabletop is viewed from above from a distance of 50 centimeter. Okay, so it's like how much is going to be appearing to be raised means the shift D is equal to T into 1 minus 1 by mu, where T is the thickness of the glass slab itself, which is 15, into 1 minus 1 by mu is the refractive index of the glass, which is 1.5. So then when you're looking at it directly above, there is no shift, no, because you're looking along the normal. But only when you're looking at it from sideways, it's going to be appearing raised. So diagram is like this. It's going to bend. It's going to bend away from the normal. It's going to appear to be raised in the pin. So this is the diagram, and so you understand. You solve this, you get your answer. So that's a direct sum. So let's go to next question. Is example 17. It's an optical instrument numerical, where the whole concept of optical instruments, the optical fiber. It consists of inner core, which is more denser, and an outer cladding, outer cladding, which is a rarer medium. Okay, 1 second, hold on.